All right, we're back at it. So obviously I got the car up on race ramps and ready to start putting this thing together. Now I've already got the engine and transmission installed in the car. Luckily, I'm sort of a one-man show, but luckily last weekend my dad came over and helped me get this engine in there without completely destroying the car. So the 363 from my previous videos that I built, it's in there. Luckily, I've got about, I don't know, an inch worth of clearance from the front pulley to the cross member in the car, and about 5 inches on each side. So getting this engine in there was kind of a bear. I'm running a Lakewood bell housing, a Tilton ST246 clutch, the Tilton hydraulic throwout bearing, and then a Tremec TKX transmission. I believe it's the close ratio, the 0.68 overdrive, or the 0.81 or 83 overdrive, whatever it is. Now, obviously it's just as easy as just throwing the engine and transmission in there. There's some things that you need to take into account. Obviously, when I got the engine and transmission in there to put the transmission on, there's a couple things you need to look out for when you put the bell housing on. And I did this when the engine was out of the car. You want to basically measure the runout on the inside of the transmission. It has to be, I think, between 10 thousandths or less of runout on the inner bell housing. Luckily mine was at like 7 thousandths or something like that. It was within spec, so luckily I didn't have to get the offset dowels. Now when you install the clutch and the hydraulic throwout bearing, you also need to measure the bearing depth, because that hydraulic throwout bearing only has so much throw, right? And it has to be 0.200 or something like that, offset from the fingers of the clutch to the face of the throwout bearing. And it's just as simple as once you install the clutch and you install the bell housing, measure the difference from the teeth to the face of the bell housing, and then from the face of the transmission to the front of the throwout bearing. And then you take that difference, adjust the throwout bearing until you get that desired air gap, and then throw it together. Now that's getting all the engine and transmission all in the car. The final step was the rear tail housing of the transmission mount. So the manual states that for optimal height on the rear of the transmission, it's got to be between 3¼ and 3½ inches from the frame, the cross member frame, to the center point of the output shaft on the transmission. So I had to take some I had some 1/2 inch thick aluminum bar, and I just cut it down and made me a spacer, and that got me within, I think it's a little over 3¼ of the height on the rear. So having all that, made sure left to right the engine was level, and then obviously with putting that spacer in the rear, make sure I had the proper amount of rake. You want to make sure all that's correct, because oil drain back, you want to go to the pickup of the engine so you don't run it dry, or when you're going into corners and stuff like that. So all that squared away. Next, we're gonna see how much I can get done today. I've got a whole table worth of parts. I still got to do exhaust. I've already built the headers, but I got to do exhaust. I've got to make the radiator hoses, fab up the fuel system, do the electrical, all the interior, the dash, the interior part of the harness, mounting the computer for the engine. So I got a lot to do, and I'm trying to get it done as quickly as possible because this is marked 6 years of this journey. So I'm ready to see this thing on the road and at the track. So let's get after it. All right, so next thing I'm gonna do is put these headers in. So I'm just gonna put, the headers are 2-piece. So there's an upper portion and a lower portion. The lower portion is a slip fit. It's basically 1 7/8 to a 2-inch, 1 7/8 primary to a 2-inch primary stepped header. But to get the upper portion of the header in, I gotta take this valve cover off. All right, here's the upper header. It's 1 7/8, stainless steel. Got all the tubing from Burn Stainless and used IC Engine Works, the basically Lego set to make these things. Let's see if they still fit. Sweet. So I am using exhaust manifold studs instead of bolts and copper exhaust flange gaskets. Let's get this cinched down. All right, upper portion of the header's done. Get snug as a rug down in there. Next, I can put on the passenger side lower half, but we got some work to do on the right-hand side. There you can see the pipes coming down at the bottom of the engine. Now this is the passenger side. Like I said, it's gonna go pretty simple here. The header installed on the passenger side. Fairly simple. Let's go over to the driver's side and I'll show you the problem we got. So on the driver's side, you can see here, I've got a foot box. That's where the pedal box is. It's on the bottom instead of up in the dash. So the headers fit in between that foot box and the outer body. But the problem is once I install the lower part of the headers, I can't get to the upper bolts that hold that foot box in case I ever had to service it. So I'd have to take the header back apart, which is kind of a pain in the butt, and I don't really want to do that. So what I'm going to do is cut the bottom of the box out and then put some rib nuts and make me an access plate on the bottom so I can still get into the foot box and service it without having to take the header apart and get to those upper bolts. So let me finish getting this foot box off and I'll show you what I'm going to modify. All right, so here's the foot box panel after I took it off the car. So what I'm going to do, since this is the bottom, this is the side you were seeing with the bolts at the top, what I'm going to do is take this little piece of scrap. It's about 1/2 inch, 3/4 of an inch wide. And I'm going to draw a line here. And then all the way along the back side, you sort of get the point. What this is going to allow me to do is to put some nut certs on this panel, and then I can make a whole new bottom panel that will bolt to the bottom of this. That way I can go ahead and leave this on there and never have to take it off again, and just unbolt this bottom access panel so I can get to the stuff that's on the inside. So let me go ahead and finish marking this off. I'll cut it and then we'll go from there. Okie dokie, all cut out. Now I'll just make another plate that's the same size to the edge, drill some holes, put some nut certs, and now I'll be able to access it without removing it. Perfect. All right, exhaust fully put on the driver's side. I finished up the box. As you can see, I did actually cut out a little access hole there for my O2 sensor, because the pipe that's coming off here, I want to put my O2 sensor as close to the collector as possible so I can get an accurate reading. So I did cut a little side hole there so the O2 will fit through there. And then as you can see, now I got full access to my master cylinders. And I don't have to take the exhaust off to do it. And there's the plate I made to go on the bottom. That should do it. I'm gonna bolt this up and then we can start making the exhaust. Let's keep on trucking with this build. So now I've got the headers, I've got this box all completed. We're good to go. I mean, I got very little clearance there, but what are you gonna do? Need more clearance, Clarence. Since this is tucked up so high up into the body there, there's these braces along the side of the chassis that mounts the body, but basically, this is the muffler. It's a Cook's bullet muffler, basically a race muffler. Straight through. It's 4.5 inches round at its widest part with a 3-inch inlet outlet. I'm gonna take these jack stands, I'm gonna try and place this where I want it. But obviously, since this is larger diameter, it's gonna have to sit down a little farther, which means I'm gonna have to sort of kick out my exhaust down and away a little bit and then bring it back level as I go back to meet the exhaust. You'll sort of see what I mean as I build it out. And I'm gonna also add this flex coupler. It's a Vibrant flex coupler. Add that in there. So I mean, this is stainless steel. It doesn't really like flex much. It'll like to crack. And with all the engine movement, I want as much flex in this as possible so it doesn't crack or break or come shooting off. So let's get to building this. Here we go, first draft. It's tucked up in there real nice. Obviously, this has got to be tacked up, but I think that's where it's going to sit. Looks pretty good. I got about a 1/2 inch of clearance above the top of the muffler before it hits one of those braces on the side of the frame. Everywhere else I got pretty good clearance. Obviously this last little piece, I just put that on there just to see about the turn, but I'm going to end up just doing a 90. It's going to come out to the edge of the tire like the originals looked. Other than that, I think we're good. I'm going to tack this up and then we'll go from there. Well, I feel pretty good about this final design. I think this is what I'm gonna go with. I was gonna bring out the tailpipe a little farther and give it sort of a slash cut. I might do that, but right now I think this fits the needs, right? So I think it's pretty good. I got this all welded up, installed. I got to finish welds on the muffler and this connector section. I've got to add the O2 bung on the back side of here and a hanger. I bought these hangers. They're pretty nifty, stainless steel, but I might have to sort of mold this to fit the back of the muffler so it fits right. But other than that, those are pretty simple things to do. That's wraps this up. We'll move on to the next thing, go to the other side, finish up that exhaust on the other side, and then move on to fuel system. All right, let's move on to the fuel system. So originally, obviously, these cars are 1960s cars, so they were carbureted. You basically have one feed line that went up to a mechanical fuel pump on the side of the block. It fed the carburetor. Bob's your uncle, you're good to go. I decided to make this more difficult on myself when I switched over. I'm doing fuel injection, so it's going to be a little bit more complicated than that, especially in this car because there is literally no room for anything whatsoever. This being an ERA car, it does have a square tube frame, and there's a lot of it. So the way this car is originally designed, so the fuel tank is above the rear suspension, right behind the driver passenger compartment. So it is up high. Typically with an EFI or a fuel injection system, you can get away with just bolting a external fuel pump on the frame rail. Since the pump's higher than the pump, or the fuel tank's higher than the pump, it'll feed down to the pump, keep it primed. That'll feed the front of the engine, should be good to go. Then all you need is a return line. But I do want to track this car, so the other option is an in-tank fuel pump. Now, the in-tank fuel pump, obviously, it draws from the bottom of the tank and pulls up, so it has to prime itself. That's really not ideal for a track car or like a performance car, because as you get to the lower, like a quarter tank of fuel, you take corners, hit the brakes, accelerate, whatever, the fuel may uncover the pickup and it'll unprime itself. You'll end up with issues like cavitation or vapor lock or all those types of horror stories you hear. So there are companies out there that make pumps that are similar to the modern OEM pump. Now, a modern OEM pump, if you take one out, you'll see that they don't look like the pumps of old. They have it's sort of a whole pump system. It's a big bucket and everything, right? So it's sort of, they're referred to as jet pumps. So what it'll do is there's two actual pickups on the bottom of the pump. It'll pull fuel from outside of the bucket, fill the bucket, and then from the bucket, it will push fuel to the engine up front. What this does is, A, it keeps that bucket full and it keeps the pump running cool, because the fuel will actually keep the pump cool. And two, anytime you're low on fuel and you make a left, right, whatever, pull some lateral G's or whatever, the fuel, that pump has enough reserve in it to make sure that fuel keeps getting to the engine, even though the outside may have sloshed around and it may be uncovered. So today there's companies like Radium and stuff that make a surge tank, which is basically, you'll still have your in-tank pump. It feeds this external tank that has another pump in it, and that acts as a reserve and makes sure you don't lose fuel pressure. I decided to go with a sort of similar product, but it was designed for like a fuel cell. So it's a surge tank and the pickup pump all in one unit. And what I did was I removed the fuel tank from the car, cut out the top to fit that unit, added the nut plate on the inside of the tank, and then fit this unit. The great thing about this unit is it's an all-in-one thing. It has provisions for your vent, it has the provisions for your filler cap, it has provisions for your fuel level. Everything's all in one. All the wiring, nuts and everything is all pre-done. And what it is it's got two pumps instead of one pump. You have a pickup pump that feeds the surge tank, and then that surge tank is actually what feeds the engine. And then the return line actually feeds right back into that surge tank. So that surge tank should stay constantly filled. The cool thing about the Radium is it also has a sort of fuel level for the surge tank, which I'm gonna wire up to a dummy light on my dash. But that way you'll know if the pickup pump is gone bad, or you're having some other issues that's not keeping that surge tank full. I'll know if the level drops too low in that surge tank, I'll get a dummy light saying, hey, there's an issue there. Anyway, so that was, like I said, there's no room in this car, and that was an extensive amount of work to get that installed because, like I said, this is originally a carbureted car, so the tank itself has a pickup or a little valve on the bottom of the tank where the fuel is drawn from and feeds the front. Well, I've plugged that off because obviously I've got that fuel system. But the problem I had was, how am I going to get the lines, the feed and return lines? I'm using -8 feed and -6 return. How am I going to get those lines ran to the front? Because the original line I think is like a 3/8 maybe even smaller, quarter inch feed line. And -8 by itself is 1/2 inch. And then I've got the -6 return, which there's no provision for. So what I ended up having to do was cut probably about a 1.5 inch by inch depth groove in the front of the tank. And then I created the stainless hard line and ran it down to the side front of the tank, because literally the tank hugs the body and the frame rails. There's nowhere else to run the line. So I had to make that, fabricate that. And then there's a aluminum pan at the bottom that the tank sits on. I just cut an access hole on that so I can run the line straight down the frame rail to the side. And then I used Earl's stainless steel bulkhead fittings. They're meant for frame rails, so they're about, I think 3 inches, 3¼ inches long. I did have to extend them by about 1 inch because the frame rails here are wider than those bulkhead fittings are. So I ended up running those lines down, ran them through the frame rail, and now I'm gonna continue to make the hard line and run it to the front. So here's where we're running into more dilemmas, right? So there is literally no room in this car for anything whatsoever. And I have to run, well, this is the fuel filter I'm running. So the pre-filter, obviously the pumps inside the tank have a sock on them, so that's the pre-filter. The post-filter, I'm using this Injector Dynamics pretty nifty fuel filter. It actually has a valve on it so you can relieve pressure if you've got to service it or whatever. And it's a standardized, once I mount this, it's actually like an oil filter. So you just press this button here, and it's like a standard oil filter. So once I mount this, I won't have to worry about it again. I won't have to take any of this off or AM fittings. I can just relieve this and take the filter out and replace the filter if I ever needed to. So that's kind of nice. So that'll be for the feed, but obviously I don't have any room to mount this thing in the engine bay. I have round slap out of room. So I will be mounting it underneath the car, in between some frame rails. And then on the return, I'll be using a flex fuel sensor. Now it's actually a sensor, and then this is an adapter from Radium. A bunch of people sell them. Aeromotive and a bunch of different folks sell this adapter. But what it does is, because the standard flex fuel sensor may not be large enough for some applications, this has like a bypass to it. So it'll actually bypass, I think you can put up to a -10 on these, but it'll bypass some of the fuel so you don't lose any of the fuel volume by running a flex fuel sensor. So I'll be putting that on the return line on the way back. So that's all the components I'm gonna be using. It's gonna be a, like I said, -8 feed, -6 return. Fuel rail's already mounted. I'm using the radium fuel rail mounted fuel pressure regulator, which is pretty nifty. It has a turn dial on it. And I also have the fuel pressure sensor on it. So everything about it's super nice and super easy to use. So let's get after it. So looking at it from the bottom of the car, you can see there's the lines I ran from the upper tank down to these bulkhead fittings. There's the frame rail, there's the other side. So here we go. So these bulkhead fittings, that aluminum right here is actually the floor pan inside the passenger compartment. I have about 1/2 to 3/4 of an inch between the floor pan and the frame rail. And I need to mount, which I've already drilled the holes for the mounting, my fuel filter in between these frame rails. Right there, if you can see that. So, since this is the floorboard though, I can't literally just run the bolts straight up from the floorboard into the passenger compartment, because then they'll be sticking up obviously. So I gotta run them down. So I'm gonna show you how I'm gonna do that. I'm actually gonna make a little plate, drill this bolt pattern out, put the bolts going down, and then weld those bolts to the plate. That way, if I ever had to service this or take it off, I could just unbolt it from right here and take it off without having to have somebody hold the bolts or whatever. So let's get to doing that. All right, got me a little piece of just standard steel plate. Just gonna draw this out, cut it out, little piece, drill the holes, and then we'll go from there. So there's the plate. There's the holes. There's the bolts. I've ground the heads off, made them flat like pins. All right, bracket done, welded on. It fits. So now, I'm just gonna hit this with some black paint real quick so it doesn't rust. Throw it in the car through the floor pan, and then put 3 rivets in it to keep it in place. And now I'll be able to mount my fuel filter. Let's do that. So there we go. The bracket's all painted, riveted in. It's flat enough I can put carpet over it, won't be a big deal. And the seat's gonna be over that, so that should be good. Now, let's see the other components mounted. All right, there's the fuel filter and the flex fuel sensor mounted on the side of the frame rail. You can see it's in this little sort of compartment in between the frame rails. I've already made one of the feed lines. You can see that there, the stainless. And it goes back, as you can see there, to the connection. And I'll show you how I made that and the tools I used to flare it and put the ends on. All right, let's talk about how I'm gonna make these hard lines. So like you've seen, I've already made the one that goes for the feed line to the bulkhead fitting to the fuel filter. I'm gonna go ahead and make the line that goes from the other return line bulkhead fitting to the flex fuel sensor. Now to make those lines, all I did was take a piece of welding wire and sort of just bend it into the shape I need to do the length. So now what I'm gonna do is use some tools to bend the stainless line. Now this isn't just standard stainless tubing that you can just buy from a metal supply or whatever. This is actually Earl's stainless tubing specifically for these types of applications for either, you know, like brake lines, fuel lines, whatever. The reason it's specifically for that is they've already annealed this metal. So it makes it so it's a little bit simpler to bend. You can use your standard style bending tools. I bend it with this fairly easily. And also when you make the flares, like what I'm gonna do, the annealed stainless steel, if you use regular stainless steel, sometimes what'll happen is when you try to flare it, it'll split. The stainless steel will actually split. With the annealed, you usually don't run into that problem. I've done plenty of flares on these so far and haven't had any issues. Now the one thing you will want to do is when you make the cut, clean it up really well, because when you make the flare, you use the flaring tool, any type of burr or material that's sort of left over, when you make the flare, it's going to embed into the metal, either cause a divot, a groove, and it's going to end up causing leaks. So you don't want to do that. So make sure when you make the cut, you clean it really well and then use the tool to flare it. Now I have two tools for flaring. One is the Earl's professional flaring kit. Now this kit is one of those deals where it's sort of has like the hydraulic handle. You'll put it in. The kit I actually bought does both the 37 degree for AN fittings and the regular, I think it's 45 degree or whatever for your standard like brake lines and stuff like that. So this tool is quite expensive, if I'm honest, like 550 bucks or something like that. Eastwood also makes this similar tool, does the same thing. This makes perfect flares, does everything you need it to do. Great tool to have if you're gonna do brake lines, AN lines, all that type of stuff. Now, I also ended up getting this other tool from, I think it's Irwin or Rigid. It also does 37 degree. The reason I bought this tool is because you can make these really shallow depth flares. So if you've got a really tight bend that's right at the end where you need to put the AN fitting, you'll probably need something like this. This is actually a lot cheaper. It's like 150 bucks. Works really, really well. But like I said, it has like a 1/2 inch thickness, where if you use the Earl's tool, that's like the hose you put in there, you're talking, what is that, 1.5 inches? So you can't really do those really tight bends close to the connector because you just don't have enough room. And I'll show you why, because the type of connectors, you gotta have the actual nut, then a sleeve, and then you make the flare. So similar to what you would do with a brake line, you gotta put the fitting on first, then make your flare, your double flare or whatever you're gonna do, and then it screws in, and that's what secures the end. So let's get to start making this. Got my 2 ends. I'll slide that in there, see what it looks like, and then I'll test fit it, cut it to length, and then we'll flare the ends. All right, so now it's time to do the flare on the end. I've got the tube cut to length, and we're gonna do this flare over here. Now, I took a piece of green little Scotch-Brite, just cleaned it really, really well, made sure there's no burrs or anything, cleaned the inside of the tube as best I could. So now, it's 2 pieces. You got this little sleeve, and you obviously have the nut, right? So you'll put the nut on first, and you'll put the sleeve with the beveled edge facing out towards where you're doing the flare. Because all it's gonna do is when you clamp it down, when you clamp down the nut, it's gonna push against this sleeve and push against the back side of the flare to give you a nice seal. So slide that on. And then I'll just clamp it in the 3/8 slot here. And you just clamp it flush, slide it over, do the side clamp, make sure everything's centered on there. And then just crank it. And then when it lets loose, you know it's to the right depth. Unscrew it, undo the clamp, slide this back, undo it, and there you go. As you can see, you got the flare. Give it one last once over, make sure there's no debris or anything in there. And that looks clean and ready to go. All right, I'll go test fit it one more time and do the flare on the other end and then install it. Okay. All finished up and screwed on. All I gotta do now is make the ones that run to the front. And what I'm gonna do is do some bulkhead fittings, make some brackets, and stop the hard lines right there at the edge of the aluminum panel. And then I'll run the soft lines up to the fuel rails. And then I should be good. All right, all the hard lines are done. Components mounted. There you go. You see I made a little bracket there before it terminates. So now I can just run my standard AN lines from that up to the fuel rails, and the fuel line will be done. So let's go on making these hoses. So the hose that I'm using is from Fragola. It's the Race Right hose. It's PTFE inside coated hose. So basically it's good for alternative fuels like flex fuel, E85, things like that. It's not gonna corrode, it's not rubber inside, so it won't corrode that. I am using the crimp fit fittings. I also have the crimper from Fragola. You can easily use the standard AN fittings that are just screw on. They work just fine. It's just, I've done a couple projects now and I wanted the crimp hose just for me, whatever. Anyway, so I'm just gonna go ahead and put this straight end on one side and then I'll cut this to length and put the other end on the other side. So it's fairly simple. You can set up the machine. You've got a dial indicator. You put the right tool crimping die in there. This is -8, So this is the die for that. And then I'll just slide the collar on, slide this fitting on, screw this collar on, and then I'll put it in the machine and crimp it. There we go, all crimped. Now let me measure it and make sure it's the correct. Use my old dial indicator, make sure 0.75, that's what it should be. All right, I'll put this on, cut it to length, put the other end on. Let's keep going. All right, I've marked the hose to the length I need. Somewhere on here, right there. So I've marked the hose where I need to cut it. So I'm just gonna wrap this in this cloth tape I have. So then I can cut it right down the center of that cloth tape, and that'll keep the exterior, the covering from fraying and going bananas. So then I can slide the coupler on, the crimp coupler on, and I won't have to worry about this hose just fraying and going everywhere. So let's wrap this and then cut it. Easy peasy. Now, we'll put the coupler on, crimp this like I did the other side, and we should have a complete hose. All right, crimped, ready to go. All right, fuel system, all plumbed. There you can see the connector. Obviously there's gonna be the transmission tunnel. It's gonna cover that because it's on the outside, but you can see that looks really nice, extremely sturdy. And then, see how the fuel lines come up. There's the return. Feed over there, and the crossover. We are good to go. So that's complete exhaust and fuel system. That's a wrap of this episode. We got the engine, transmission installed. We got the headers, we got the exhaust built, we got the fuel system, the plumb. So we got a lot done. Now we're gonna move on, we're gonna start doing the electrical stuff. So the body electrical is already in the car for like the headlights, turn signals and all that stuff. The wiring harness, obviously I had it on the dyno stand, so that's all good to go. All I gotta do is finish mounting the bulkhead fittings for the wiring harness for the outside to mount to the inside harness, and I got to mount the inside harness and then figure out where I'm going to put the computer and the O2 sensor readouts. So that'll be next. Next episode, that'll be it. We're going to be finishing up the electrical, get the fuel pump in the rear, electrical plumbed in, and then hopefully fire this thing up for the first time. Once it fires up, there's no leaks, everything's squared away. I can slap the interior in it, do some finalizing stuff here and there, and then we'll be ready to get this thing registered. Stay tuned.